Hello everyone, welcome back for another video. Today we'll be covering inverse functions. So we've got our objective up there on the screen. We'll be using the definition of inverse functions to identify ordered pairs and tables of inverse functions. And we'll also be writing equations of inverse functions. Now, to start with a definition, we talked about inverses last week in terms of inverse operations and doing the opposite. So now we're going to talk about functions and relations in terms of inverses. And the first big idea today is what an inverse relation does. And the word up there, interchange, that just is another word for the word switch. So what an inverse relation is going to do is it's going to switch two parts of a relation. And those two parts are the domain and the range. Now, we know that the domain represents the function's x values and the range represents the y values. So basically what an inverse is going to do is switch the x and the y values. So we'll start here with a table. We have an original function, blue, containing the ordered pairs 0, 5, 1, 0, and 2, negative 3. Well, all an inverse function is going to do is take all of those ordered pairs and reverse the x and the y values. So our first ordered pair there of 0, 5 for the inverse becomes 5, 0. The second ordered pair 1, 0 becomes 0, 1. And the final one, which is 2, negative 3, now becomes negative 3, 2. Note that none of the signs changed or anything like that, but we did switch the x and the y values. Now, a little bit on notation here. The original function, we read that as f of x. When we have an inverse relation, we use the same notation, except along with that f of x, we put a negative 1 slightly above, and it kind of looks like an exponent, but it doesn't represent an exponent. It's just the notation we use for the inverse. And we call that f inverse of x. Now, we can also see inverses in terms of a graph. So what you'll be asked to do a few times here is graph a function along with its inverse on the same coordinate plane. So we're going to start with graphing f of x equals 4x minus 2. And Algebra 1 does a lot of graphing. This is a linear function. And one way that we can graph functions is by creating an xy table and plotting some points. So when we do that, we just take some x values. And it doesn't really matter which x values you use, although I like to use at least one negative and one positive. And to find those y values, we simply substitute the x's into the function. We learned that earlier in this unit, in fact. So if I went in with the negative 2, that gives me negative 10. If I substitute in the 0, we get negative 2. And finally, if we substitute in the 2, we get 6. So I can plot all of those points on this graph. The graph extends to negative 10 and positive 10. So negative 2, negative 10 would be all the way down here. 0, negative 2, like so. And 2, 6 would be up top. And that's a nice linear function. We can go ahead and plot those points and connect them. And that gives us a graph of f of x in blue. Now, if we wanted to graph the inverse, all we would need to do differently is take those ordered pairs and reverse them, put them on the graph, and we've got what we need. So negative 2, negative 10 becomes negative 10, comma, negative 2. And likewise with the other ordered pairs. I'm just switching the order of the x and the y values. And now I plot those points. Negative 10, negative 2 would be over here. Negative 2, 0 right there. And 6, 2 would be up here. Now we got a little sloppy there. The smartboard has got a mind of its own every now and then. And we connect those points and we see that. Now, it can sometimes be hard to see how these blue and green lines connect in terms of the graph. But what I've done is I've put a pink line in the middle. And if you look at how that is set up, you should notice that the pink line is exactly halfway in the middle of the blue line, which is the original function, and the green line, which is the inverse. And that is not only going to happen on this problem, it will happen with all of inverses and the original functions, because inverses will always show a reflection over that line going down the middle, which has an equation y equals x, and is also sometimes referred to as the 45-degree line. 45 degrees because a right angle is 90 degrees, and 45 is half of that. So it's half of the 45 degrees, half of the 90 degrees. Okay, so we will always see that reflection. Now, the last thing I wanted to look at in this video, just to prepare you for our lesson on inverses, I wanted to briefly go through how we find equations of inverses. So we see that working with tables and ordered pairs is pretty simple. Finding equations of inverses is a bit more challenging. To find the equation of an inverse, we have two steps. First, we will take the x and the y and the equation and switch them. And then we will solve that equation for y to get y by itself. So I've got two examples down here, and we'll just do a couple in the video. We'll spend the majority of our class time working on these inverses. But our first one with y equals 5x. What I'll do here is I'll take the positions of the x and the y, and only the x and the y, and switch them. So instead of y equals 5x, the y becomes x, and the x becomes y. Now that is the inverse step itself, but we always want to solve the equation for y. So we think, well, what's over there with the y, and how do I get rid of it? Well, we've got a 5 in front of it. If I want to get rid of that 5, I should be dividing. Remember, if we don't see an operation, the operation implied is multiplication. The opposite of multiplication is division. And that means that our inverse here is y equals x divided by 5. In our second problem, y equals x squared plus 9, we'll again start with the first step, which is switching x and y. Note, I've only switched x and y, none of the other things. And now I need to get y by itself. I have over here y squared plus 9, so I want to think about my inverse operations. What's the opposite of adding 9? Subtracting 9. And now a lot of times with these, students aren't really sure what they should be writing down on the left-hand side, but you can't combine the x and the minus 9. So we simply write x minus 9. Over on the right, we still have y squared, and we want to solve for y, meaning we want only y. So you ask yourself, how do I get rid of y squared? How do I get rid of the squared part? Well, the opposite of squaring, as we said before, is square rooting. So we'll take a square root of both sides. That takes me back down to just y. And on the left-hand side, don't try to do anything here. We simply bring down square root of x minus 9. And that is my final answer for the inverse. One thing to realize here is that when we solve for the inverse, we have everything exactly the opposite of what the original equation had. In our first example, we had 5 times x. The opposite of multiplying is dividing. And in our second problem, x was being squared, and we were adding 9. And in our final answer, we had a square root and subtracting 9. So that's one way to check and make sure that your inverse equations have been done properly, is by looking to see if the operations you have in your answer are exactly the opposite of what you started with. But that's it for this video. I hope you got a little bit of an introduction on the idea of inverses. And we will be starting with more equations of inverses in class next week. Thanks for watching.